Number 6, final answer should have been -1. Sorry, we're checking 4.1a for anybody who's not here. -1 over x squared plus c. However, is there another way of writing that? You could have done -x to the -2. You could have kept the 2's there and not reduced them, but of course reducing is probably the best way to go. But should you have already known that was the right answer because you could check it? Yep. Good call. All right, let's keep going. What's the next even?
18.
18. Here it is. Final answer. 3 over x to the 7th, or another way of writing it would be 3x to the -7th, right?
No, that's the original after you derive it. Check it.
It answers
Oh, lame sauce. You're right. -1 over 2 x to the 6th, or -1/2 x to the -6. -1 over 2 x to the 6th, or -1/2 times x to the -6. Both of them are acceptable as long as there is a plus c. Sorry, that goes back to the original. Next one.
26.
Here it is. I got it now. Secant y minus tangent y plus c. You guys been working on your trig derivatives? I hope so. Next one. Yeah, that was 26. So it's right here in the middle. Sorry, kid, because it checks on the second step. Secant y minus tangent y plus c. I missed it. What was the next one? 28. Thanks. Final answer, 2x squared plus cotangent x, to get the right sign, plus c. Next one.
44.
This was the one that gave you f double prime, and what were they asking for? F, which means you had to go backwards twice, but that also means you had a C and a D, or like they showed, a C1 for the first plus C and a C2 for the second plus C. So how on earth were you able to get all the numbers plugged in at the end? They gave you
Points.
So they gave you a clue for the first derivative and a clue for the original function. You were able to plug into the first derivative to solve for C1, or the first plus C, which was 6. Then you had to anti-derive again to go backwards from the first derivative to the original. Then you had another clue to plug in for the original function to find C2. Hence the final answer, -2 ln of absolute value of x plus 6x minus 3. Got it. But is there another way of writing it? Is that a pen? Yeah. Let's get better over there. Is there another way of writing it? My iPad's not working yet. But, just preparing you guys for the AP. Couldn't we have done that one? Plus 6x minus 3?
Yeah,
Why?
because
Check it. The AP loves to change LNs. Keep going, Ren.
it's the log rule. You have the coefficient in front, you can put it into the power inside the log.
And if I put it in the power, then it's ln x to the -2. -2 means 1 over absolute value of x squared. Why is the absolute value gone?
X squared is always-
Anybody squared is always positive. I don't need the absolute value. Does that make sense? Anyway, just letting you know, because the AP loves to rewrite LNs and then trip you out as a result. I need to go up here, which is above the board, go over here and do that, over here and do that. Okay, that took forever. What's next? Oh, nice. 4.1b. Change homeworks. 4.1b. Looking now? Okay. What's my first even, or are there any evens? 54. I knew there was. Why -9.8? Because they said use gravity as -9.8 meters per second squared, and if you didn't read the directions, you wouldn't have known. Okay. They had to start with that and then integrate back. They gave you some clues, like the initial velocity. Oh no, they didn't give it to you, did they? Huh. Plain sauce. Integrate back. I think they plugged in. Did they give you initial velocity of 10 meters per second? An initial position of 2 meters? Okay, so they gave you the initial velocity. You were able to plug and chug. You get the final position function. Watch the mouse, negative 4.9 t squared plus 10t plus 2. But then they were asking for maximum height. Do you guys remember from class what happens when there is maximum height? Do I know how high? No. But what do I know?
Velocity is 0.
Velocity is 0 because the slope of the tangent line at the max is 0. It's a critical number, smooth turn, etc., etc., etc. So what did they do? They took the velocity, which you could have also plugged in for. They set him equal to 0. They solved for the time, and it wasn't asking for the when. It was asking for the where or the how high. So they solved for t, plugged it into position, and ended with 7.1 meters. Angela, did that answer?
Yeah.
Oh, got it. Is that the end of 54? 7.1 meters? Okay. Any other evens? 60. Here it is. There's an A, B, and C. Let me give you a second to check it out. If you can tell, there are some intervals in letter B. There was a sign chart you were supposed to do. Letter A, they're asking for the velocity and acceleration function. Is that right? Bridget, go ahead.
Can you explain B? I didn't get that.
B was asking the question, hold on, someone check it, who wrote it down, when the particle or the object or the car or whatever was moving right. From our motion packet, let me zoom to the notes real fast. In our motion packet, I think it was right here somewhere, hold on. This page. Nope, this page. Yes. Okay. When we were answering in our motion packet, filling in some clues, we had different things like initially, t is 0, at the origin, etc. But then we also talked about what it means for, or what's going on when the particle is moving to the right or up, or to the left or down. If it's moving to the right, position is increasing, we say, because it's getting more positive. If position is increasing, then velocity is positive. So this was a classic increasing, decreasing sign chart problem. When they asked when it's moving to the right, they're saying make a sign chart and check where the velocity is positive. Does that make sense? So you would have done a first derivative sign chart over here, and that's why it looks like intervals. They did a first derivative sign chart, they checked the signs of the first derivative, and they were saying, hey, in between 3 and 5, can anybody help us out? Why did they get 3 and why did they get 5?
Factor.
Yeah, because they set the velocity equal to 0. They did critical numbers. So velocity equal to 0.
The sign chart was 5/3 and 3.
Oh, what's 5? Did they give you? Oh, they gave you 0
They were
to 5.
balanced 0 and 5.
Got it. So it would have been cut off at 5. Would have been cut off at 0 from what they told you up here in the beginning, 0 to 5. Then your critical numbers would have been in between 3 and then 5/3. And even though you could have done like x prime, you could have also done velocity because that is the first derivative that you're trying to do the sign chart with. Remember, just plug in a test point. And the only place it was positive, meaning the velocity was positive, was there, which means that's the only place you could say position is increasing. But what does that mean? In this example, moving to the right. And then we have C being t equals 7/3. That's setting the acceleration equal to 0. And plugging into velocity, which ends up being negative 4/3. A little bit tricky to find all the work, but did you guys check it? All right, any other evens? 62. Oh, he's right here. Why aren't you scrolling? Okay. 62, he has an A and a B. give you a second. Start with cosine, take the integral. This is one where it's not a constant acceleration, it's a variable, so you have to just integrate it, antiderivative like we've been doing. You have plus c. Then they wanted you to integrate again to get to position. They gave you a couple clues, which is how you end up with negative cosine t plus 4. Letter B is asking when it stopped. Is that right? Something like that?
Can't remember.
That's what you're supposed to write directions. You guys are killing me.
What the directions they were break to linear motion.
Well, that's what's going on. Who drew directions for B? What's it ask for? Stopping points? Or the velocity of 0? No one had it in there? Oh my goodness. I've started taking him off points for that.
Got it right.
So velocity equal to 0. Sine equals 0 at any multiple of pi. I would have done pi n from pre-count. You guys could have done k pi, pi n, whatever. Whatever.
Find the values of t force of particles at rest.
At rest. What does at rest mean? Stop. What does stop mean? Velocity is?
Zero.
Got it. Any more evens?
64.
Oh, yeah.
Can you explain how you use this to then and how you basically find the constant?
They're saying that whatever this object is started at rest because it's saying the initial velocity was 0. Either they explicitly stated that or they stated something about, Ryan, do you still have the problem?
Yes.
Please read it for us.
Okay, a particle initially at rest moves along the x-axis.
Initially at rest. So they were able to say the initial velocity was 0, which means when they took the integral and got sine of t plus c, initial velocity, remember, is when t is 0. Since sine of 0 is 0, then c, the constant, must equal the initial velocity, which is 0. Does that make sense? So plug in 0, initial, t is 0. What's the initial velocity? It says at rest equals 0. Sine of 0 is 0, c equals 0. So therefore they were able just to cancel out the first c. Because it just equals 0. C1, hold on. This clue leads us to v of 0 equals 0 equals, pardon the running out of roomness, sine of 0 plus c1, right? What is sine of 0? 0. What does c have to equal? 0. So therefore they plugged in, oh hey, he's 0. So then they were able to say velocity is just sine. Okay? And then if velocity is sine, how do you get to position? Take the integral. Integral of sine, negative cosine. Now I have a new c, but they gave me, Ryan, keep reading, another clue.
So it's that its acceleration of time, t is greater than 0, is given by a of t is equal to cosine of t. At the time t equals 0, its position is x equals 3.
At the time t equals 0, the position is 3. Set that equal to boom, 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 boom. Plug in 0. Solve, solve, solve. Cosine of 0. Negative cosine of 0 is negative 1. So therefore, move the negative 1 to the other side. C2 must be 4, hence where they got the final equation. Does that make sense? All right, any more evens, guys? That's it? Oh, 64. Oh, that's right, because I didn't want you doing any other ones. 64A, where's A? Oh dear, he's way down here. 64A, 73.33 feet, or, something nasty.
Wait, and it's not pretty.
Oh, wait, no, you're supposed to use that. Keep plugging in. We had two different positions at two different times, 73.33 and 117.33. Get down the answer for right now. How many of you guys have a question on 64A? That's it? Oh, you didn't get there? Alright, I'll make a copy of it for tomorrow, that way we don't kill time today. 73.33 feet and 117.33 feet. This was a very wordy one. I was just trying to see how you guys did, but let me get, right now it's going to take too long, but let me go ahead and try for tomorrow to get a picture of it and we can check it out. Sound good? Come on. Alright. Remember done?
Yeah.
Alright, let's go ahead and grab out our motion packet. You guys should have it pretty close. Remember, all that is taped. If you guys need to go back and check it out, but 64A, I'm going to go ahead and retry. Why aren't you looking? We'll get a good copy of it tomorrow so we can all check it out together. But motion packet, I want us to look at a couple things. On Friday, what were you supposed to check out on the motion packet? 1, 2, 3, but I said start at 3. So let's peek at 3. We're not going to peek at 2 or 1 today. We're just going to peek at 3 because he was the first one. We might peek at 1 or 2 tomorrow. So if you guys didn't get a chance to really play with it, maybe now you can. Yeah. No, I just said examples 1, 2, 3. We'll come back to that. Probably we need to get a little further in integration before I want to talk about that one. But thanks for checking. Alan. Yes, you may. Don't get lost, bud.
Don't get lost, Alan. You can get a QR code.
Yeah, but that doesn't work. Sadly, I tried that one.
It's okay.
Air server works better. Hold on. Contemplate life for a second. Alright, I'll keep using the mouse for now and just hope this connects at some point today. Alright, let's keep going. Here we go. I need one of these guys. I need one of those guys. That's great. Alright, for number 1, what'd you guys do?
Oh, I did. It is moving to right.
Take the derivative because if it's asking right or left, read velocity, right? The sign of velocity. So take the derivative, that'll get us velocity, and we're plugging in. Are we plugging in 0?
Yes.
Alright, what'd you guys do when you took the derivative? You don't need me to take the derivative. That's power rule. And plug in. What'd you get? Positive or negative?
Positive.
Positive. So you plug into the derivative, you plug into velocity, and then you get a positive. What does that say? The particle is moving to the...
Right.
Got it. That's all you had to do. You had to take the derivative, plug in 0. It's a positive number. Sweet. Right. Christian.
Are we grading this with a
Preferably... Yeah. Yeah. For example number 3. Remember, example numbers 1 and 2 we're not doing today, so you can go ahead and maybe work on it a little bit more tonight. So we're on example 3. This is worksheet 2. Now guys, I'm not totally solving it, so if you need to write this down, write it down, but then you can fill in the work, like actually take the derivative and plug in 0. True? True. Number 2, how do you answer the question?
Derive again.
Because it says velocity increasing or decreasing, so who do I need the derivative of this time? Velocity prime. And who am I plugging in? 1. And for those of you that didn't do the work, we're skipping steps and you need to fill it in pencil later, that's fine. But for the rest of you guys, when you took velocity's derivative, what'd you get, positive or negative?
Negative.
Which means? Decreasing. Now the explanation of your answer, we'll wait until my iPad is in the land of the living. And I can write that nicer. This whole explanation is really good practice for FRQs or free response questions, but that won't be our point today. Number 3, find all values for which the particle is moving to the left. Wait a minute. Hold on. What's true if it's moving left?
That means
What's negative? Don't say it. Velocity is negative, right? How on earth do I figure out intervals where velocity is negative? I need a sign chart. What kind of sign chart?
A sign chart.
What kind of sign chart?
One
Who
velocity.
am I plugging into?
Oh, velocity.
Velocity. Who am I getting critical numbers from, aka setting equal to 0 and solving? Velocity function. What critical numbers did you guys get that already solved for velocity and set equal to 0?
1
1
and
and
3.
3.
1 and 3. Question, in the problem, did it say time is everything or was it cut off?
Time is everything.
Okay, so for right now, I'll just leave 1 and 3, yeah?
Yeah.
Where did the velocity end up being negative?
In the middle.
Just here. Sweet. So my final answer, some of you guys need to Show the work like actually find velocity, set it equal to 0, show that it's 1 and 3, the critical numbers. If I can say time is within 1 to 3.
Yeah.
Is that good?
Yes.
Does it give any units like seconds or any of that craziness? No. Alright, then we're fine. Hey look, that's backwards. Anyway, find the total distance traveled by the... How are you supposed to do total distance?
I don't know.
Don't worry, put a question mark.
Oh, good. Good, thank you.
Wasn't he the one that we skipped, number 11 on the first page, total
I don't
distance?
remember.
Do you do the calculator thing that you taught us like really early in the year?
You could, but don't forget to put absolute value. Because total distance, we need to have all the positive changes and negative changes added up positive. Does that make sense? Yeah. And Ryan, that's where we're going, but since we haven't technically talked about definite integrals, I'm saving it. Alright, put a question mark and say no big deal, yo. So, tonight's homework, unofficially. Try example 2 and try example 1, but real quick, let's recap. Example 2, you're given a graph of who again?
Good one.
Velocity, which is the first derivative of position. So think graph of first derivative. In example 1, what are you given? A table of velocity with respect to time.
Whoa.
Now, hold on, I'm just going to help on number 1, so if you want to skip there, I'm going to help on the very first one on number 1. Example 1, number 1. I'm giving answers. Example 1, number 1. If it says particle moving to the right or left, what am I looking at? I'm looking at 0, and I'm looking at the velocity, and I'm saying, hey, buddy, are you positive or negative? What? Go team, that's an answer if you can figure it out. All right, cool kids, we're stopping with all of that in the sense of examples 1, 2, and 3. You're trying examples 1 and 2 tonight if you didn't have time before. But in your motion packet, can I have you guys actually go ahead and turn to worksheet 3. I'm thinking, especially with my iPad not working, we're not going to start section 4.2 today. We'll see how time works out. I might introduce it. But there is one more piece of the motion packet we can do right now, and it is important. But can I have you guys also open up your notes? And before we go back to the motion packet, let's go ahead and tack this on to 4.1b, because you guys haven't taken any other notes, right? So let's tack this on to 4.1b, which was motion, right? I want you guys to write down the following. I want you guys to write down the following, and I'm going to keep playing with the silliness of it. Let me pause the video for a second, just because you guys are just writing. Okay. In our motion packet, just a second ago, we did have a question, or maybe it was in homework, where the question was asked, where is velocity increasing or decreasing? In question. Velocity and speed, two different yet related things. Velocity has a what component that speed does not. They both say how fast. Velocity says also in what direction. Like a vector, right?
Yeah.
In the sense of a vector had not only magnitude but also direction. Velocity has a direction, meaning if velocity is positive and it's a right-left model, where are we headed again? To the right. If velocity is negative, where are we headed? To the left. If it's an up-down model, if velocity is positive, then we're headed up, and if velocity is negative, then we're headed down. That's why acceleration is negative for gravity, pulling down, but that's a little different. Okay. Now, speed is what? Just how fast. Just the magnitude. Just how fast. Your speedometer is only positive, right? Now, hold on. Get everybody awake in your groups real quick and looking at me. Get everyone awake really quickly and looking at your groups. All right. So, coming back. When is, listen to my words, when is velocity increasing? Where would you look? What else would be true if velocity is increasing? What's positive? Why acceleration? Because velocity's first derivative needs to be positive for velocity to increase. That's the increasing, decreasing test. A quantity is increasing when his derivative is positive. Whose velocity's derivative? Acceleration. So when acceleration is positive, velocity is increasing, which means velocity is getting more what? What does it mean if velocity is increasing?
Getting more positive.
Getting more positive. Because velocity sign matters. When is velocity decreasing?
Acceleration is negative.
When acceleration is negative, which means velocity is getting more negative. Now, before we answer this question, what it means to speed up and slow down, I need you guys to realize speed increasing is not necessarily when velocity is increasing, and speed decreasing is not necessarily when velocity is decreasing. In your motion packet, we're going to go ahead and do a quick little discovery. We should be able to finish it by the end of class, I hope. A quick little discovery. We'll mostly do it together. In years past, we've taken extra time on it. We just don't have time today because of all the things that have slowed us down. But here we are, worksheet number 3. Real quick. At the very top, you guys shout it out. Speed is the absolute value of velocity. We already know that. It tells you how fast something is moving without caring about the direction in which the movement is happening. Number 1, this is just math. What does absolute value have on numbers? Makes it positive, right? Always positive. Number 2, what effect does taking the absolute value of a function have on its graph?
Everything above the x-axis.
Vertically flips portions below the x-axis. Does that make sense? Portions above the x-axis stay the same. It vertically flips any portions that are below the x-axis. Bless you. Now, for each situation below, we're going to have some clues and we're just going to try and fill in. That's all that's going on, alright? So here what's going on in situation number 1. Velocity. This is a velocity graph. What is velocity doing? A, velocity is, let's answer the questions and we'll come on back. Is velocity positive or negative? How do we know? Is if it's above or below. So all the velocity in the first quadrant, is it above or below? Are the y values or the velocity values positive or negative? Positive. And is it increasing or decreasing? And we're able just to look at the graph because it's asking about velocity and we have velocity. Does that make sense? We're just looking at it. It's above, so all the y values are positive, and it's increasing. Because we know velocity is increasing, we know acceleration is positive. That's just from the increasing, decreasing test. Now this says by examining the graph of speed. Hold on, we haven't done speed, okay. Speed takes any portions below and flips it up and keeps the rest the same. So guys, is anything flipping? No, it stays the same. So you can sketch speed. Struggle. If only I could sketch it straight with my little silly mouse. Speed's going to be the same thing. Just pretend it's the same thing. So what's going to happen to all your y values? Absolute value of 1 is 1, 2 is 2, 4 is 4, 8 is 8, 16 is 16, right? So kiddos, look at either speed's graph or look at speed's numbers. What's speed doing? It's equal to velocity, and in this case, it's doing the exact same thing as velocity, meaning it is increasing. Real quick, what was velocity's sign in this example? Positive. And what was acceleration's sign? Positive, which means in the model, it was going a speed in the right direction, and acceleration was saying, hey, I'm going to push you more right. Oh, that makes sense. It might speed up. Situation number 2. All right, what do you see? Velocity, is it positive or negative? Because it's below. I have a graph of velocity, I'm checking it out. Velocity is below, so velocity is negative. What is velocity doing? Decreasing. Okay, circle decreasing. Because velocity is, acceleration is, good, that's just increasing, decreasing test. Does that make sense? By examining the graph of speed, we'll think, hold on, speed. Speed takes anything below, flips it above, anything above stays the same. Where's speed? Wait, what? Velocity is decreasing? What's speed doing? Hold on, let's check out the table. Does this make sense? -1, speed is what? -1 just means 1 in the negative direction. The speed is 1. How about -2? How about -4? Velocity is getting more negative, but as velocity gets more negative, the speed gets more positive. What's going on in this model? I'm speeding up. Speed is increasing. Wait a minute, what was acceleration sign? No, sorry, what was velocity sign? Negative. What was acceleration sign? So velocity, you're headed to the left, and acceleration is saying, hey, I'm going to push you more left. See, acceleration is negative. So velocity is going negative, acceleration is negative. They're working together in my model. I'm speeding up, but to the left direction. Does that make sense logically, kind of? Can you tell from the graph in the table pretty simply? You guys zoom ahead and do situation 3. We'll check your answers in just a second. If you finish 3, go to 4. There are 4 in total. Couple more seconds. Okay, a couple more seconds. 5, 4, 3, 2. Situation 3. What's going on? Velocity is negative because it's below and increasing. Velocity is increasing, so therefore acceleration is positive. Speed is pause. What'd you guys do in the graph? Keep it the same or flip it? Flip it. When you flip it, oh my goodness, what does it look like speed's doing? Does that make sense with the numbers? A negative number is getting more positive, hence why velocity is increasing. But what's going on to the magnitudes? 16 is going to 8, is going to 4, is going to 2, is going to 1. What am I doing? Speed is, aka I'm slowing down. But velocity is increasing. But wait, velocity is a negative, acceleration is a positive. They are working against each other. Look at my hands. Velocity says I'm going left, acceleration is saying I'm pushing you right. If they're working against each other, what's my object doing? Slowing down. So then in situation 4, when you guys got there, you looked at your graph, what was velocity? Positive and decreasing. Since velocity is decreasing, acceleration is negative. Speed is, what'd you guys do? Flip it or keep it the same? Keep it the same. Just pretend that stays the same. I don't even know. Okay. Okay. That's better. The numbers, what ended up happening to them? Well, they just stayed the same. Positive is easy because everything just stays the same as what you would expect. So since velocity is a positive, acceleration is a negative, once again they're working against each other, and speed is decreasing. So, question, when was speed increasing? Situations 1 and 2. Velocity and acceleration had the same signs. When was speed decreasing? 3 and 4. They had what kind of signs? So what are we going to fill in our notes? Speed increases. You speed up when they have the same sign. Speed decreases. You slow down when velocity and acceleration have different signs. Kiddos, what's homework tonight?
Finish that one.
Try example 1, try example 2. Don't worry about number 2 because of circumstances unforeseen. We did other work instead. However, peek over the speed thing. You might have a little pop quiz. Not that's worth a lot, but just to see if you actually get it. So think about it tonight. Yeah, it's like filling in blanks. But be careful. I promise you some of you are going to get totally messed up tomorrow. Bye. It's not the same thing you guys was asked.